Hi there. Welcome to Intro to Processing video number 4, and this is our second video on PVectors. So we're going to take you a little deeper into PVectors. You're actually going to get the chance to learn something about vectors themselves in this one. And you can see by the length, this one's going to be a little bit longer, so hang in there. You'll see that over here I have a sketch. It's up and running. You can see the palette, the bouncy balls running around. You'll recognize this sketch as the one we were playing with in the previous video. I got it right out of that chapter on PVectors. Just copied and pasted it right in there. You'll see there's some other stuff going on down here that we haven't seen before, and I'll talk about that a little later in this video. You'll see there's another sketch in the background, and I'll be talking about what that sketch is going to do for us. But again, this is about getting to know vectors a little more. And I want to show you what ultimately your goal is. You got this bouncy ball bouncing around like that, and I'm going to stop it for a second. I'm going to start it again, and I want you to pay attention to where the ball moves first. Where does it start, and which direction does it go? Did you see that? Try it again. Where does it start? Which direction does it go? See that moving down to the right? Okay. Your goal is this. I'm going to one more time. Your goal is to make the ball do this. Now, you don't get to see the sketch. I actually hit it. It's scrolled up there. I don't want to give away the answer. But your goal is to get the ball to do this. Let's watch that again. Where did the ball start? In the same spot, by the way. But watch which direction the ball goes to begin with. See that? In this one, the ball starts out going down to the right. Your job is to get the ball to go up to the left. And I'll just, it's going in the opposite direction to start with. The key is the opposite direction. Now, that's all done with vectors, and I got to warn you, to get the ball to do it requires one little change in the sketch. We're going to talk a little bit about vectors so you have an idea about where to go and what things to try, so you're not just hunting and fishing for hours trying to figure that out. So we're going to learn a little bit about vectors, a little more, and we're going to go to our book to do that. Here we are in the chapter, processing.org. We're at the tutorial on PVector, the one we were looking at yesterday. This is the one we kind of thumbed through. It's very dense, technical reading. There's the bouncy ball sketch without PVectors that we copied and used. There's a bunch of talk stuff about vectors. I don't get it. There's some diagrams. We're going to actually talk about those diagrams in this video. More information, lots of information, more sketch stuff. Oh my gosh. More stuff about, oh, look at all the math here. More diagrams about these things called vectors, whatever those are. And then we got down to the bouncy ball sketch with PVectors. Okay, and that's the one we copied in also and used. All right, and it's actually the one that's running right now on my screen. So a little bit about vectors. It turns out you've actually been playing with vectors for quite some time. You just never knew it. It's something you use in real life, and it's actually something you've been doing with mathematically as you've been working with the XY coordinate system. This is what a vector does for us, and I'm going to be very specific about our application. They have more general applications also in different areas, but for what we're talking about, it's about position. Positioning the ball and then moving the ball. Vectors help us with that, and here's how they do it. Suppose you're standing right here, and you want to go to this point right here. Well, of course, you would just walk along that diagonal to get there. That's pretty easy. But if you wanted to tell someone how to get there, it might be hard to say, walk along that diagonal, because they're going to say, what diagonal? How much do I angle? I mean, what's going on? So instead, you can do this. Hey, from wherever your position is right now, I want you to change your position. The way I want you to change it is I want you to move 3 steps to the right horizontally. And then I want you to make 5 steps up vertically. 3 steps to the right horizontally, 5 steps up vertically. 3 horizontally, 5 vertically. And the way we record that is just like this. 3, 5. And that is a vector. The vector tells the person where to go next. That's called a velocity vector, because that's what velocity is. I don't know if you've thought about that very much, but if you're in a car and you say, hey, I'm driving 50 miles per hour east, you've just described how your position's changing. You have just said, oh, in the next hour, my position will be 50 miles away from here directly to the east. That's a velocity. It talks about changing position. Vectors in this case, with velocity, talk about how your position changes. Okay? That's what vectors do for us. And we describe them just like we do ordered pairs in a coordinate system, because it's about how far horizontally did you move and how far vertically did you move. So, started right here. Hey, I want you to change your position by going 3 to the right and up 5. Horizontally 3, vertically 5. That is vector talk. And you've been doing that kind of stuff. And that's how you write the vector. You just simply write it 3, 5. That's not too hard. That's not bad at all. That's what vectors are. Sounds crazy. Why do we give them special names and all that stuff? Well, just the way they become more general in mathematics. But for our application, it's about position and changing position. So, once again, original location, new location. Let's go horizontally and then vertically. Now, let's go back up here. I'm about to give you a major hint how to solve this challenge that we've given you about how to get that bouncy ball go the other way. Here's the major hint. It goes like this. Suppose you were here and you wanted to end up there. Notice that the vector would be pointing the opposite direction. Well, you would tell someone, hey, to go from here to here, instead of going to the right 3, you're going to have to go left 3. And instead of going up 5, you're going to have to go down 5. So you'd say, hey, go down 5 and left 3. And you'll end up there. So that vector is the opposite. It's in the opposite direction. It goes this way. And look what happens to the numbers. They become opposites. This becomes a -3. And this becomes a -5 because you want to go down 3. I apologize. You want to go left 3 and down 5. So it would be a -5 and a -3. So if this vector from here to here is 3, 5, the vector taking you back is -3, -5. No, that's pretty simple. That's not bad at all. And you've been playing with that kind of stuff. Keep that one in mind. Let's go back to our sketch. Let's see where that's happening in our sketch. So we're going to look at this one. And the first thing I want you to notice is that right up here in the sketch, we're telling the sketch, hey, we're going to be using with some vectors. We're going to be playing with some vectors. I'd like you to make 2 vector locations. Excuse me, that's the wrong word to use there. I would like you to make 2 vectors for us. We'd like one of them to be named location and one of them to be named velocity. That's what this code is doing in this sketch. Please make 2 vectors. Call one location, call one velocity. Now, in our application, it's expecting that location will have an x and a y value, and velocity will have an x and y value. Let's go down and look where they're being used. Look where location is being used, and look where velocity is being used. Let's talk about what these are doing. Location is telling the ball where to start. In this case, where to start. It's saying, hey, when this at setup, I want the ball to start at a location 100, 100. That's on the palette. Now, the coordinate system for the palette isn't like the coordinate system we have you work on in math. It's a little bit weird in one direction. We start in the upper left-hand corner, first of all, not down in the lower left-hand corner. We start in the upper left-hand corner. X is positive this direction, and X is negative in this direction. X is 0 right there. Y, it turns out, is positive in this direction, and Y is negative going up from there, and Y is 0 right there. So a little bit different, but it still works. You still have X positive, Y positive. So if the ball is going to start at location 100, 100, that's going to be to the right 100 and then down 100. And you played with that in the last video. You were playing with that because you made the ball start in the upper left-hand corner, and those are the numbers you changed to make it happen. Okay? Next, there's a velocity vector. Now remember, velocity tells you how much to change your position by. And what this velocity vector is saying is, no matter where your position is, I want you to make the x value 3.3 bigger. And I want you to make the y value 5 bigger. That's how I want you to change your position. Wherever you are, like if you start here at 100, 100, no problem. I want you to change your position in the x direction by plus 3.3. Move right, 3.3. Change your y by 5. Move in the y direction, 5. In this case, for processing, that would be down 5 from where you're at. So, no matter where you start, this is where we start, great. Velocity vector says move to the right 3.3 and move down 5, and there's your new position. I want to show you that happening. That's why I've made this stuff down here show up. The line of code that does that, by the way, is this line right here. You're welcome to put that in your code if you wish. Just make sure you copy it exactly. You forget one little thing like a quote mark or a parentheses, it won't run. But you're welcome to put that in. That print is printing out these lines. Now what's scrolling by are x values and y values. That's what you're seeing down here. It's going by way too fast though. So I'm going to show you how to slow it down. I'm not sure if you've seen this before. I'm going to shut this one off so it's not so distracting. You can add another line of code. It's kind of cool. You can control the rate at which it refreshes the screen. It defaults to 60 frames per second, which means this draw loop right here runs 60 times in 1 second. It goes through this 60 times in 1 second. So the reason the ball is moving is it's being drawn in a new location, and it does that 60 times every second, and you can change that. That's the default. If you want to say, oh, you know what, just change position just do it 10 times in 1 second. Let's see what it looks like. There it goes. No surprise there. It's only changing 10 locations every second. It's only running through that loop 10 times every second. We can make it even slower. Go through the loop once every second. So this draw loop will be executed. It's going to draw one bouncy ball every second. When we run that, there it is. Let's go even slower. That's every 1 second. Let's make it go every 2 seconds. What should I put in there? What should I put in there? Yep, 0.5. We want a half. Now, that screen's going to refresh every 2 seconds, which means it's only going to draw a ball every 2 seconds. See that happening, how slow it is? Nice and slow. Now, remember, location starts at 100, 100. So when you start this, notice where the ball starts. Right there at 100, 100. Then the velocity vector says, oh, I'd like you to change the location 3.3 to the right and 5 down. Oh, okay. Let's watch that happening. Let's start this again. Watch the numbers down here in the console when we do this again. You should see it start at 100, 100. There it is, starting at 100, 100. Now look what happened. See the x changing by 3.3? See that? X is increasing by 3.3 every time. Every time it goes through the loop, it increases the horizontal distance by 3.3. Let's do that again. Look at the y location. It starts at 100, and then look, it's increasing by 5 each time we go through the loop because we told it to. This velocity vector is telling it how much to change every time it does it. Every time, please move 3.3 to the right and 5 down, and that's exactly what's happening. Now, this is where you can get bossy. You can say, hey, you know what? I want you to move 10 to the right, and I want you to move 8 down. Doesn't matter which one's bigger. That doesn't matter. But we should now see it start right here at 100, 100. And we should see the x value gets 10 bigger every time, and the y value gets 8 bigger every time. Remember, y getting bigger goes down. Let's watch it happen. It'll start at 0, 0. Excuse me, 100, 100. There it is. Now look at the x value increasing by 10, and the y value increasing by 8. Notice it's bigger jumps for the ball, so look what the ball's doing. The illusion is that the ball's going faster. So we made the velocity numbers bigger, and the ball goes faster. As a matter of fact, if we go back and do this, Remember this at 60? How fast the ball looked? Watch how fast it looks now. Holy smokes. Holy smokes. We increased the velocity, so the ball's going faster. Oh, that makes sense. Yeah, that makes sense. Now, let me show you where the action's happening. Because remember, what we talked about is that you have a position vector. The velocity vector tells you how to change, and you get the result by adding the velocities together. By adding the vectors together. Here's where it's happening, right here. This is in the draw loop. This is where the vectors are being added. The location vector is being added to the velocity vector. Every time you go through the loop, this happens once. Whatever your current location is, increase it by the velocity. Let's slow this one down again to watch that happening. Go down to 2 seconds again. Let's get that running. And it's this line of code right here that is making the ball move. Location started at 100, then we added the velocity, so location became, what are our numbers? 110, 108. Then the next time through the loop, it increased again. These numbers are increasing, and these are increasing because these two vectors are being added. Position vector, add the velocity, you get a new position vector. Come through the loop again, new location, add the velocity, you get your new location. That's what's causing the ball to move. So that's a lot. It's been a long time me yapping at you, just about done. I just want to remind you now of your goal. Your goal is to, let's put this back to 60, to take the ball that's moving like this. I'll get things back to original. That's how it was to begin with. Here's that ball moving. Notice it's going to start in the center, move down to the right. Your goal is to go into the sketch and make the ball do this. Now remember, I gave you a major hint to the solution at the beginning of the video. And I also told you that it's actually a pretty simple change to make. The challenge is, where in the sketch should we make the change? There's a lot going on here. Where should that occur? And what change should I make? That's your challenge. And think about what vectors are. Think about how they control the motion of the ball. And think about the major hint that I gave you in the beginning. And get that ball to go the other way. Okay, so your task in doing so, get that ball going the other way. Let's see a screencast of the change that you made. You explaining the change just like I show you in this video, the changes that we make. Show that in your screencast and get that posted so we can look at it. And nice work with vectors number 2. You're one step closer to understanding vectors, and I appreciate your patience for this long video. Hopefully they won't be that long in the future.